Yeah. Okay, one of you, Preet, do you have the data from the question that we did last class?
Yes, sure. Not fine.
Is it from the board or?
Yeah, from the board. Remember the question we did last class? Somebody have it on there? Okay, somebody want to go write it?
I would.
Clean, right?
Quickly. All right, did I give it to you in order originally? Doesn't matter.
No. You didn't give us.
I'll just put it down.
I wasn't it. Was it with the math scores? No, this is
This is it.
The quizzes.
Yeah, was it with jumping the stages?
Okay. It was this many?
No.
No way, man. No way. It was like 5 data points or something. This is a question on like the... No. Yeah. This is nonsense. Erase this. Erase this.
Remember he gave us like part A and part B, like to find the standard deviation, standard deviation.
Oh, that one. 6, 4.
Erase it.
Yeah, that one.
Yeah. Crap.
And why does your numbers get bigger?
It doesn't matter. Just write them down. As I gave them in the original... Yeah, perfect. Okay, so calculators. You can film it now if you want. Oh, it's already started? Okay. What? Shh, can I get some quiet here? Because I know how to do this. I don't really know. I know how to do this already. Okay, first things first, turn the machine on. Take a look over here. This button on the bottom left, on. Got it? The next thing that you want to do is you want to clear the memory of the calculator. Okay, you see the plus button. You see above the plus button the MEM writing in yellow. You need to activate the yellow writing by pressing the yellow button over here, second function. Press that, then press the plus button. Okay, now you see option, it should be option 7 for most of you. If not, look for reset. So you can either scroll down using these buttons or just press the number associated with the option that you want. I'm going to press 7. Your options are all RAM or defaults. I don't want to clear the defaults. I do want to clear the RAM. So for me, it's option 1. I can hit 1 or hit enter. Then it gives you one last chance to back out. Basically, are you sure you really want to do this? That's what it's asking. And I do want to do it. So I am going to pick option 2 for reset. Okay. Now the RAM is cleared. Okay. That way you don't have any data that's stored in your lists or so on and so forth. Okay. So now we want to enter data into our list and see if I can remember how to do this. I believe, let me just try this feature for a sec. No, that's after. No. Bear with me for 1 second. Okay, got it. So what you want to do now is you want to press, you see this button, that's the stat button, S-T-A-T? You want to press that button, and then you can see, look up here, you have 3 columns, edit, calc, test. Take a look up here for a sec. You see how it says edit, calc, test? We want to stay on the edit column, but try for the hell of it. Scroll to the right. Look, when you go under calc, you have different features. When you scroll over to tests with the arrows, you have different features. Okay, Arthur, let's go. Let's go back to the edit feature. Okay? Are we all on the first tab? And you want to pick all 3 of them. Can you pass the attendance to the young lady behind you? Thank you. Mark them, please. Okay, so we're going to actually pick edit underneath the edit tab. So you can hit enter or press 1. And now you have a spreadsheet. Shh, guys, please don't make any noise. You have a spreadsheet, right? You have the different columns. They're labeled. Most of you should have them labeled in sequence, L1, L2, L3, L4, blah, blah, blah. But some of you have them out of sequence. It's all good as long as you remember where you put your information. So we haven't used L1. We might as well put the information L1. You could put it in L2. You're making noise. Away. Like, just sit. Do me a favor. Just sit down. Next time, come on time. Okay, so what we're going to do is we're going to enter our data in L1. So 6, enter 4, enter 9, enter 8, enter 7, enter 8. I think, okay, you see this negative down here? You guys know the difference between these two negatives, this negative and this negative? This one is when you want to have a lead negative. Like, this is when you're putting negatives in between terms, okay? So if you were entering, let's say, a -4 in here, you'd want to use that. Okay, so now the data is in. Now, well, let's just say that. Okay, the next thing that I want to do is this. I think the calculator is not defaulted to give you all of the information that you want associated with statistics in this course. Okay, it's defaulted to give you some of that info, but not all of it. So you need to turn that feature on, which makes sure that it'll show you everything you want. And that feature is called diagnostic, or diagnostics, I can't remember. And the way to access it is through a catalog, where all these features are listed and you can activate the ones you want. And if you take a look above the 0, you can see catalog in yellow. So let's press the second function key again and press the 0 to access catalog. Now this thing is alphanumeric, sorry, this thing is alphabetical, so you can either scroll down, like you can literally hold down the cursor until you get to diagnostic on, or I think you can get there quicker by pressing the green alpha button and the letter D, but whatever. I'm just going to hold this button down, good enough, hold the down arrow until I get to diagnostic on. You see there's off and on. You want to go on the diagnostic on feature, and then you want to hit enter. And now you'll see it on the screen with the flashing cursor. Hit enter again until it says done. Okay? So now what you've done is, if you wouldn't have done this, I don't think it would give you, like, I don't think you would be getting standard deviation. I can't remember which ones, but if you didn't do this, you'd go to do analysis and then you'd only get some of the information you want. And then you'd be like, where the hell's all the other stuff I need? Then you'd have to say to yourself, oh, I forgot to turn diagnostic on, okay? So you might as well just turn it on at the beginning. All right, so we have data in, we have diagnostic on, right? Now, is this one variable or two variable statistics? One variable statistics. There's no y versus x here, dependent versus independent. You just have a bunch of data, okay? So it's a one variable statistic. So we wanted things, if I'm not mistaken, like median, mean, mode, variance, etc., etc., etc. Eric, I'd like you to write above that sample of population. Okay, that's important. Why is that important, guys? What number is good? What two numbers that's going to make a deal for? Standard deviation or variance, right? So quickly, it doesn't have to be beautiful. Sample of pop. POP dot. Good enough. Okay, so we want to get the information. So let's press the stat button again. And let's scroll. I think we scroll to the right to the calc tab. And you can see that you have two options. You have one var stats, two var stats, etc., etc. We care about one variable statistics. So you can either hit enter or press the number 1. Either way, it'll work. Now, it should say one var stats with a flashing cursor, right? What we want to do is we have to tell the machine where, in what list this one variable, I'm wondering, is it one variable statistic or one variable statistic? Yeah. We need to show the machine where our one variable statistics are, right? And they are in L1. And if you take a look above the number 1 in yellow, you'll see L1 in yellow. So press the second function key and press 1, okay? And I know I'm forgetting to, no, I don't need to allocate anything else. I don't think so.
So can you go back, like on the calculator, like if you want to?
To go back, I generally hit stuff like clear and so on and so forth. I don't know if there's a back button per se.
Press delete.
Yeah, you can press delete. Delete will kind of. Now I'm going to hit enter. Okay? And you can see that it's giving you an X bar, right, of 7. Now it doesn't use the multi-symbols. You're not going to see a mu, right? So you might be like, well, wait a minute, this is average for population, sample population X bar. It's not mu. But mathematically, is there any difference between X bar and mu?
No.
No, the only difference is between sample and sample of pop and pop come to variance or standard deviation. So but that will be taken care of, as you can see. So you can see here, average is 7. You can see they give you the sum of the x data, the sum of the square of the data, and so on and so forth. And now you see S sub x and sigma sub x. And of course, S sub x is bigger. Why is S sub x bigger than sigma sub x? Because S sub x is for a sample, and for sample standard deviation, the denominator under the radical is n minus 1. So which of these two is appropriate for this question, S or sigma? S, because it's for the sample, right? So you would quote 1.79-ish, right? Agreed? Any questions for that? If you want the variance, you'd have to take that value and square it. Yes, agreed? I don't think they squared for you. They give you the number of data points. Continue to scroll down. Look at that. Total number of data points, your minimum value, which would be the bottom of your whisk, box, and whisker, Q1, the median, Q3, the maximum. So it does that for you. And actually, somebody showed me one year that it actually, there's a box, it'll actually draw the box and whisker plot for you. I don't remember the feature, but who cares? It's like, do you guys understand that it's done? Do you understand? Look, there's the minimum of 4. So there's your 4, and then there's your box, your Q1, your median, your Q3, and your other whisker. Now the other thing, actually no, I think it'll do a modified box and whisker for you as well, so that you might not have to do that calculation of the 1.5 times the box, but I can't remember offhand. You can look for that if you so choose. Okay, so everything, Q2 is the median. MED is the median, which is Q2, right? So there's what you need to know in terms of how to use the graphing calculator for one variable statistics, which is what we're dealing with in this particular chapter, right? Any questions on that so far? Now, my advice for you on tests and so on and so forth, let's say you're doing a test, this was one question, you had another question. I would press the stat button, I would hit 1 for edit, and I would scroll over to L2, and I would put information L2. In other words, at the end of a test, if you want to look over everything, because obviously if you enter data incorrectly, you would have a different answer, better than erasing everything would be to keep as much information as you can in your machine, so at the end of your test you can go back and be like, let me check over question 1. Okay, did I enter all the data right, and so on and so forth. I think there's a maximum of like 5 or 6 lists or something, so, but whatever. Okay, is that pretty clear? Yeah. You guys want, how many of you guys want a few minutes to like look at it with each other, maybe ask each other some questions? Okay, so why don't you guys do that, and we'll reconvene in a few minutes. Okay.
So what would be not as you said this is just one axis?
I don't even know what you're saying. Watch your head, Milad. Okay, Milad says he has found the way. Start with the other side. It'll make it nicer.
Look at that, it's there.
Did you see that face? No, sir, it won't.
That's cool.
Why not just expand the other side? It's so much easier. I can't really see what he's doing right now, so.
Sir, you will see.
I'll look at it after.
Look at the confidence.
But he has confidence all the time, whether he's right or wrong.
Can I just
Yeah. Watch your face. I can't see anything yet, to be honest, so when he's done, I'll look over there.
Is there a substitute for what he wrote in the second?
Is there a substitute for?
For what he wrote in the second term, he replaced that. What do you call it? Sigma sign?
Yeah.
With mu?
Oh no, the x bar?
Yeah.
Well, you need to know that. I mean, remember, average is equal to the sum of the data over the number. Okay, so let's see what Milad did here. Okay, so we got the right side. Okay, so the first substitution that he's making is right over here. Right? And he's just using a definitional substitution because you know that average, right, is equal to the sum of all of the data, right, divided by the number of data points. So then he's just multiplying both sides by that. And he's saying that sum of data is equal to n times average. So he's replacing this with that over there. Okay. So that's his first move. And let's take a look at his third line, which is the second move. So then he applies the square, right? You guys know that going back to grade, I don't remember, right? If you have the implied exponent on the n and the x bar are 1, so n to the 1 squared becomes n squared, and x bar to the 1 squared becomes x bar squared. So that's good. And then next, he factors out an n from the two top terms, from the two terms in the numerator under the radical. So he factors out an n. That's going to leave him with sum of x squared minus n x bar. Sorry, minus n x bar squared, which is what he has up there. He gets rid of the n's, he's done. Any questions? It works. I was going to do it the other way. I was going to start.
Can you show the other way?
Yeah, but there's nothing wrong with that. You need to understand that too. There's nothing wrong with it.
Yeah, I get it.
Yeah? Any questions on that?
Sure. How can the sigma x squared minus n x bar squared equals to sigma x minus x bar squared?
Look. Oh, wait, sorry. Oh, right. You're saying this part right here?
Yeah.
How we jump from here to here?
Yeah.
Ah, good point. I didn't notice that.
Yeah, that's where I stopped.
Yeah, where's... He's going to... Well, let me think. Yeah, can you take us through that? Milad?
N x bar
Yeah.
is like you have sigma x to the power of 2.
You have to put it in your proof. Put it in your proof. You have to put it in your proof. Sorry, I didn't notice that. My apologies. That's good, Ken.
Doesn't that make sense?
He's almost there.
Yeah, no, yeah.
You might have to erase your last line. Just erase your last line. Watch your head.
You can't write anything, it's just like explanation.
That's pathetic. There's no such thing as you can't write anything. You have to be able to write it all. If it's easy, you should be able to write it all. I know I can do it, but I want to see you do it. Well, yeah, Aaron. Yeah. How's he going to get up? Oh, don't give me this. I can't explain how to do it. Yeah, that was good, Ken. I didn't even notice.
That's where I was stuck.
Did you understand how he did it up to that point?
Yeah.
Okay. Good? You're done?
Yeah.
Okay. Why are you giggling? Does that mean you're not as confident anymore?
That's right.
Okay, so... Hang on a second. These are gone. So there's a denominator. That is that. And then,
How's that?
how did you jump from here to here?
Okay, so you have n times the
Write it down.
Right.
Write it down.
Oh.
You have that, right? You wouldn't get full marks for it.
No, it's not squared. That's almost like n times x bar.
You'll lose marks on it. You'll lose marks on it.
No, that x
Now, you want to change that, or do you want to leave the n? Okay, so you want to change the n. So what he's going to do is he's going to say that n is x, is the sum of x. Similarly, you can say that n is the sum of x over x bar. Okay?
Yep.
You rearrange that equation. That's what you want?
No.
What do you want?
I'm saying that n times x bar is the same as sum of x bar.
Okay. So you want to rewrite it like this. Right? Now you're going to replace this. So why didn't you do that? I mean, what? You're giving me the face.
No, I'm not doing that.
Like, that was just so hard to do. That was just so hard to do. I don't know how I did that. Just so impossible. Okay, so this is like, if you have x times y squared, isn't that the same thing as x times y times y?
Yes.
So he has n times x bar squared, which is the same thing as n times x bar times x bar.
Oh, yeah.
Agreed?
Yeah.
See how they actually see what's going on there?
Don't worry, Milad, you're pretty close. Don't feel ashamed of yourself.
Yeah, you
Okay,
done with
now he's going to take this piece again, and he's going to use the exact same relationship as before. And x bar is equal to sum of x. Is that what you wanted? That's what you wanted? You sure? So what did you want? Do you even know what you wanted?
No, not anymore.
So are you full of it?
Yes. Oh, Milan. Oh, no.
Nice.
That's so sad.
You're a good used car salesman. Okay, let's see if we can. This feels very familiar, like another problem that.
Sure, what's the next step, though?
Well, let's try and finish. He's very close. So let's just. Oh damn it! Oh no, but that's. That's because that's quantity, right? Oh Milan, why did you make me do this? Okay.
Even Mr. Segev has
I thought it was.
Sure, but I think
I could do it. I could do it.
Oh,
I'll do it. I'm trying to do it from your garbage. I'm trying to work backwards.
Again.
Like I've done before.
Oh, yeah.
God, you have such attitude.
that sounded so.
It's not working. You can't do it, man. I'm trying to help you here. What the hell with you? What the hell with you? Okay, I'm gonna do mine over here.
Oh, sorry, you're doing the left side or the right?
I'm gonna go on the left side. The left side is easier.
So we should forget about that?
No, let's try and fix his garbage as well. So I'm just gonna start with the left.
Segev versus Milad.
Okay, I'm gonna drop the I1 to n and the x sub I. I'm just gonna leave it as x, okay? Remember I told you once that like you know with radicals, square root, you don't put a 2. Like when people do stuff like this, you can write that, but it's implied. So I'm not gonna put in the I equals 1 and the n on the top and the x and the I because it's gonna be understood that I mean that, okay?
Yes,
It's gonna save time for me. Okay, so I'm gonna have x minus, I feel like I should draw these sub I though. I don't know. Okay, I'm just gonna expand first. And then afterwards we'll go back and fix the obnoxious person solution. Now make sure you understand what I'm doing here. This is not pretty.
So you just expanded it, the a plus b squared for
Exactly. Expansion of that is a squared plus 2ab plus b squared. So what is xi? You have xi squared, and then you have this times this is xi x bar times 2 is minus 2 xi x bar, and then you add to that the square of the n. You guys see that?
yes.
Okay, now, I believe I told you that sum of, let's say, a plus b plus c plus dot 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 is the same thing as sum of a plus sum of b plus sum of c plus, right? Yep. I told you that you can, so I have a sum of three things, so I can break them apart into three sums. So I can create that, and I can create, we'll do it step by step. You know what kills me? The way Milad walks up here with such arrogance, he's just like, you don't have to do that, man. He's just like, I'm just like the best genius, so my name is Milad. I don't have time. I don't have time for you.
You just open the bracket, right?
Yeah, I did this. And I proved to you that you could do that. Remember? It's in your notes.
So on the test, you have to prove that again?
No!
To use it? Okay.
Oh. No. That's a little much. Okay, now let's do, with proofs, it's nice to always look at what you're trying to get to. So this is what I'm trying to get to, right? This line here. Okay. I see sum of x I squared there. No, wait, yeah, like that. But I don't see this. So maybe, I don't see any x, do you see any x bars over here? I don't see any x bars over there. So maybe a good idea for us to get rid of the x bars. And to get rid of the x bars, we're going to use the exact same thing that Milad used, which is the fact that x bar is average, and by definition, it's sum of the data divided by the number of data points. So let's do that replacement.
What's the top? Sum of
Now,
sigma.
am I going too fast?
No.
Also, actually, wait a minute, before I do that, hang on a second here. Is x bar a constant?
Yeah.
Yeah. Did I prove to you guys that you can take a constant out of sigma? Let me do an aside. No.
You didn't teach us that.
Okay, two things. Yeah, I taught you this. I taught you that the sum of I equals 1 to n on a constant is equal to n times the constant.
So that's what I was trying to do over there.
I don't know, I don't care what you're trying to do, it doesn't matter. I showed you this before, right?
Yeah.
Because it's the same thing as just constant plus constant plus constant plus constant n times, right? But also, did I show you that sum of constant, let's say, xi from I equals 1 to n, that's the same thing as constant times sum of I equals 1 to n of xi, that you can just take the constant out like that? Does it make sense? Because let's say the constant is 5. Let's say this is 5xi. You'd have 5x1 plus 5x2 plus 5x3 plus 5x4 plus dot 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 plus 5xn. You'd have a whole bunch of 5s in each term, so you could just factor out the 5 and just do the sum. So guess what I can do? Take a look over here. You see this 2 and you see this x bar? X bar is a constant, right? I could take these two and go zhup, put them right out here, right? Take them right out. So I can go 2x bar sum of xi. I could do that.
Sure, but
And now, yeah,
how's that going to get rid of the thing?
it's coming.
Oh,
And this guy, I could get rid of that sigma actually, because this is a constant, right? So I could replace this whole thing with n times that constant. So I could go n times that constant, which is that. Do you guys see that? No?
yeah.
Because this is sum of a constant. And using this thing, sum of a constant is just, from I equals 1 to n, is just n times the constant.
So basically, didn't you just rearrange it?
I didn't basically do anything other than what I did exactly what I just said. I don't know what you mean by basically. I don't know what you mean. You're taking what I did and turning it into.
So did you not rearrange it?
I took the 2 and the x bar out of the sigma for this term.
But they're all multiplying, so it doesn't really matter what order
I
you
don't know what you're saying. Do you follow? Who follows what I'm doing so far? No? Who's lost? Okay. Let's say you had sum of I equals 1 to 5 I equals 1 to n of the number 5. What does that mean? Well, you start with a 5, and then you add to it a 5, and then you add to it a 5. How many times?
5n.
N times, which is the same thing as n times 5. So when you have the sum of a constant, it's that you can just get rid of the sigma and go the number of times you added it times the constant, right? Now also, what if you had sum of from I equals 1 to n of 5 times xi? Well, that would be 5x1 plus 5x2 plus 5x3 plus dot 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 plus 5xn. Factor out the 5, you get 5 times x1 plus x2 plus dot 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 plus xn, which is the same thing as 5 times sum of I equals 1 to n of x sub I. So what does that mean? When you have a constant inside a summation where there's a variable, you can take the constants out and leave the variables in. So these are 2 different moves. So here's the first move. So the second move here where you can take a constant out, that's what I do here. Because this is a constant and this is a constant. So these 2 constants can come right outside of the sigma, and then the only thing you're left with in the sigma is xi. You see that? And then over here, you have sum of x bar squared. Well, what is x bar? It's a constant. Is a constant squared a constant? Sure. So this whole thing is a constant. So here you have sum of a constant. And the sum of a constant is n times the constant. So for this one, I replaced this whole thing with just n times the constant that was in the sigma. And you'll see why I do that in a second. Do you see that? Jun, do you follow that? Ken, do you follow that? Now, we'll use that definition, and everything is going to work out perfect. Because we're also going to generate an n. And I need an n right here. So now you have, now it gets easy. What is x bar? X bar is the same thing as sum of x I over n, right?
So sum of x.
And then you have another one of these. And then this, again, x bar is sum of x I over n, but it's all squared. Okay, now it's going to go downhill. Okay.
So you forgot the square root.
Where? This one?
The whole square root.
Okay.
What's better than
Now, should I do the common denominators now?
n?
Yeah. You see all this? This is going to have, well, it's going to be, rather than me writing a whole other line, whatever, I'll just do it. I'm going to work over here now, okay? I'll just work here. I'll do it step by step, one step at a time. No change yet. Actually, can I put these 2 together? Oh, sorry, I don't know where the 2 went. I'll do that. Okay, if this is like, say, y and a y, it's y squared, right? So can I just make this minus 2xi?
Square over n.
You notice I can't put the square here, it's different. Do you guys know that this does not necessarily equal this?
Yes, sir.
They're not the same. This means sum of x times sum of x. This means sum of x times sum of x. This means sum of x times x. They're different.
Yes.
Okay? So we have that. We
Over
have,
n. So not over n?
it will be. It's going to be over n squared.
What about the second end?
Oh, you mean this end here? Yeah, you just put that in. Okay, take a look there. So all we've done here is we've combined these two. I've combined those two to make that squared, and I've expanded this to make that squared over that squared.
You can simplify it.
Now, if you have one end on the top and two on the bottom, you can get rid of one on the top and leave one on the bottom. Now you have an n here and an n here. Let's make common denominators and multiply top and bottom of this by n. So we're going to go all the way over here. So we are going to get n sum of x I don't really need to do the sub i's, but just so we fit, minus 2. Is he still talking? Is he still talking? Because I'm trying to
Sir, you can just do the common denominator ones first. That would make it easy.
Let me finish, please. So I have to multiply top and bottom of this by n, which gives me that. And then the other two already had n's under them, so I don't have to change them.
Sure, question.
Now, let me finish. If you have a over b over c, right? That's the same thing as a over b over c over 1, which is the same thing as a over b times 1 over c. So guess what? I can make one denominator which just has these two, the b and the c in it. So that's just going to be the same thing as now, I wouldn't usually write so many steps, but
you can't extract that. This is x squared times that.
Technically, shouldn't there be an I here?
This is this as well. This is this. Yes.
And now you have one last line. Look, these two are like terms. This is like minus 2y plus y. What's minus 2y and y? Minus y.
I did this here. Look.
And that's it. You're done.
Oh, sure, it's still magic.
Wouldn't be another way to do this, sir.
I never said that. We can work Milad's backwards, but it's going to take a little while.
But that's assuming all.
Mila is pretty close.
No, you can't.
That's how you do a proof, Milad.
You can do that. No, that's allowed.
Close, but never get it.
This is the sum. This is the sum. Yeah.
Sir, you use it up.
What? No, there's more. Hey, did you follow? Can you finish? Oh, you want us to fix that one? You got it? Go. Kate's gonna fix Milad's. I have no issue with it, but you gotta fix it. You couldn't do it. You quit. Go ahead. You want, just erase what I wrote and then finish it. Okay, Kate, watch your head. She's gonna just.
That's why you need the brackets.
This is pretty sick, sir.
With brackets, it's not. You can't. This is wrong.
Guys, you may want to see that.
No, but it's not excellent. It's a constant.
Xn is not a constant.
X bar is.
X bar is.
That's it.
But this is.
That's exactly what it is.
You can't extract that.
Oh my god, man.
Oh, you're so funny. I know what you're doing.
Sir, you got it too.
We have to digest this information. Okay, so she's doing that. She's just. Do you guys see what she's doing?
Yes, sir.
It's like if you had x. Is x the same thing as 2x minus x?
Yes.
Is x the same thing as 2x minus x?
Yeah.
So what is she doing? She's taking the second term over here, which is n x bar squared minus n x bar squared, and she's saying it's the same thing as minus
Plus.
minus 2 of these plus 1 of them. Right?
So smart.
It's just taking this term and making it into 2 terms. Do you see?
So smart.
Got it? She's making it, she's working it all backwards to create the reverse of the expansion. Which is what I didn't want to do. I just had no desire to do that. I don't think that way.
I don't think they do.
How can you just extract?
I don't know how you
What? You can't. She's not doing anything wrong. Hang on, let me see. She can, but she has to do an extra step. Yeah, you can't just jump from here to here. How can you just jump from here to here? You need to, but she can, you know what she can do? She can write all 3 terms, leave it, it's fine. She can write,
Sure.
But like the sum of x squared is basically x1 plus x2 squared. You can't just extract x squared.
yeah, but she can, you've got to work it backwards. Yeah, you can't jump, you've got to, she's going to have to turn, she's going to have to,
I think I got it.
you're going to have to create, so look at half here. We got minus 2. You need to, yeah, she needs to turn this. Now you need to turn this, right? And then you need to turn, and you need to turn this one.
X bar equals this, like sum of x over n. It's over here when it's x bar with this, like that's x bar squared, you get this. And then after this, you get n squared and like n squared over here. This here like only n. Yeah, and then we make like denominator, just goes n here. Then we get this.
Yeah, that's what I did.
Explain to me why.
Sure. It's just like
This is sigma squared.
Okay, let's see.
look.
This, yeah, this works, right? Because
There's an extra angle.
I think
This isn't just this square. If it was just this square, if there wasn't brackets here, then yes.
Eli, be quiet. Eli, you're out of it. You're out of this game.
There are brackets. Okay, just look at this. Look at this. Look.
Better know the property.
Okay, fine. X bar is a constant. So look, let's say x bar is 3, for example, right? 3 plus